By the end of this lecture, you should be able to know how to interpret the substantive effects of a dummy variable's coefficient in regression, know how to interpret the substantive effects of a continuous variable's coefficient in regression, know how to interpret the substantive effects of a logged variable's coefficient in regression, and know how to interpret the constant in a regression. Before I discuss how to interpret the substantive effects in a regression, I'd like to review the material from the previous lecture. In regression, we start out with a dependent variable and one or more independent variables. Our hypotheses tell us whether our independent variable should have positive or negative effects on our dependent variable. To run a regression in SPSS, we click Analyze Regression Linear. We put the dependent variable in the dependent box, put all the appropriate independent variables in the independent variable box. Once you run your regression, the last table in the output tells you the coefficients for each of your variables, the constant, and the significance test results for the coefficients and the constant. The first row tells you the statistics associated with A hat. The B column tells you what A hat is, and the SIG column tells you the results of the significance test. The next rows tell you the statistics associated with each independent variable. The B column tells you what the B hats are for each independent variable, and the SIG column tells you the results of the significance test for each B hat. In order to interpret the significance test for each B hat, you start by looking at the sign of B hat. If it is not in the right direction, B hat is insignificant and indistinguishable from zero. You do not have support for your hypothesis. Alternatively, if the sign is in the right direction, move on to the next step. Next, look at the value of SIG for the B hat. If SIG is less than 0.002, the coefficient is different from 0 at the 0.001 level. If not, move on. If SIG is less than 0.02, the coefficient is different from 0 at the 0.01 level. If not, move on. If SIG is less than 0.10, the coefficient is different from 0 at the 0.05 level. If not, move on. If SIG is greater than 0.10, the coefficient is not significant and is indistinguishable from 0. You do not have support for your hypothesis. If the coefficient is insignificant, you do not make any conclusions. You do not have support for your hypothesis. If it is significant, then you can interpret it. When you interpret the coefficient, you note what the sign of the coefficient is and what level it is significant at, 0.05, 0.01, or 0.001. Then you note if the variable has a positive or negative effect on the dependent variable. If it has a positive effect, you say, as the independent variable increases, the dependent variable increases. If it has a negative effect, you say, as the independent variable increases, the dependent variable decreases. If you are running a regression with multiple independent variables, do not forget to add all else equal. Now I'm going to show you how to interpret the substantive effects of independent variables in regression. First, I will start with dummy variables. A dummy variable is a variable that only takes on two values, usually 0 or 1. For example, if you have a variable that measures democracy, it could be coded 0 for non-democracies and 1 for democracies. In order to demonstrate how to interpret a dummy variable in a regression, I will use the following example. Imagine you are conducting a study where life expectancy at birth is the dependent variable and democracy is the independent variable. Democracy is a dummy variable. It is coded 0 for non-democracies and 1 for democracies. Your hypothesis is life expectancy at birth is higher in democracies than in non-democracies. In other words, you expect democracy to have a positive effect on life expectancy. Here are the results of the analysis. The coefficient is positive, as expected, and the SIG value is 0.001, which is less than 0.002, indicating the coefficient is positive and significant at the 0.001 level. You have support for your hypothesis. As democracy increases, life expectancy at birth increases. Not only do these results show you that democracy has a positive effect on life expectancy, the results also show you the specific positive impact democracy has on life expectancy. The positive coefficient B hat tells you how much higher the dependent variable is in the 1 category of the independent variable than the 0 category of the independent variable. In other words, the positive coefficient B hat tells you how much higher life expectancy is in democracies, the 1 category, versus non-democracies, the 0 category. Since the B hat was 5.603, you can conclude life expectancy at birth, the dependent variable, is 5.603 years higher in democracies than in non-democracies. Many students have trouble interpreting the substantive effects of dummy variables. If you are having problems, this template could help you interpret the effects for a positive coefficient. The dependent variable is B hat units higher in the 1 category than in the 0 category. Here, if you do use this template, make sure to insert the dependent variable name, B hat, and the names for the 1 and 0 categories. Next, I'm going to show you how to interpret a dummy variable when you expect the independent variable to have a negative effect on the dependent variable. Imagine you are conducting a study where gender inequality is the dependent variable and democracy is the independent variable. Democracy is a dummy variable coded as 0 or 1, 0 for non-democracies and 1 for democracies. Your hypothesis is gender inequality is lower in democracies than non-democracies. In other words, you expect your independent variable to have a negative effect on your dependent variable. Here are the results of your analysis. The coefficient has the expected negative sign, and the sig value is 0.000, meaning the coefficient is negative and significant at the 0.001 level. You have support for your hypothesis. You can conclude that as democracy increases, gender inequality decreases. Not only do these results show you that democracy has a negative effect on gender inequality, the results also show you the specific negative effect democracy has on gender inequality. The negative coefficient B hat tells you how much lower the dependent variable is in the 1 category of the independent variable than the 0 category of the independent variable. In other words, the negative coefficient B hat tells you how much lower gender inequality is in democracies, the 1 category, versus non-democracies, the 0 category. So, since the B hat was negative 0.136, you can conclude gender inequality is 0.136 units lower in democracies than in non-democracies. Note that I did not put negative 0.136 in this statement. I only put 0.136. Since I stated lower here, it is clear that democracy has a negative effect. Once again, students have problems interpreting the substantive effects of dummy variables. If you are having problems, this template could help you interpret the effects for a negative coefficient. The dependent variable is positive B hat units lower in the 1 category than in the 0 category. If you use this template, make sure to insert the dependent variable name, the value for B hat, and the names for the 1 and 0 categories. And make sure not to include the negative sign for B hat. Once again, since you're saying lower here, it is assumed that B hat has a negative effect.